Okay, again, good morning. Sorry if I was late. So yeah, we'll start with this week's topic. It would be about class design. So we've been having classes na no for the previous week. So we're creating our own classes, but we're not really creating like multiple classes, and the interaction between the classes that we create medyo minimal lang siya. So for class design, we're actually discussing here the remaining three pillars, no? Because I have said that encapsulation is one of those four pillars of object-oriented programming. In this week, in this topic, we will be discussing your inheritance. I've been talking about inheritance since last week. We'll be talking about your abstraction, and we'll be talking about your polymorphism. Two of which today we will discuss. So we'll start. Let's start. So topics for today is inheritance, and then creating your abstract classes, implementing interfaces, and lastly, your polymorphism. So for this lecture for today, we'll just be discussing 1 and 2. So your inheritance and your abstract classes. So let's start with your inheritance now, introducing class inheritance. This happens in Java when you are calling extends. We'll see later how it goes now. So inheritance, this is creating a child or a subclass of an existing class. So the subclass which you create includes all the public and private, public and protected members of the superclass. There you can also access some of the private members. However, this should be done through the superclass. We'll see more of it later. But if you have a subclass, your subclass has access to both public and protected members. So what does that mean? You have your object references and your primitive variables. You also have your methods. So these three, if it's public or protected, your subclass can access that member of your superclass. Okay. In Java, we only have single inheritance. So Java only allows one direct parent class. We'll talk about more on inheriting multiple classes because Java does not allow it, but you can do that with interfaces. But take note that for inheritance, like direct parent class, Java only allows one. However, there can be levels of inheritance. No? It's just like real life. No, your grandmother or your grandparents have a child, which is your parents, and your parents have a child, which is you. So it's same. No, in Java, your class can inherit from a parent class, and that parent class can inherit from another parent class. So here is how you extend or you implement inheritance in Java. So it's just similar to defining your class. You have your abstract or final keyword. We will talk about more of the abstract keyword later when defining your classes. You have your class keyword, you have your class name, and then this is the keyword if you wish to implement inheritance, no, or you want to extend a class. So the keyword is extends, and then this is your parent class. So for example, here you have your class name elephant seal. It extends seal. So seal is the superclass or the parent class, and elephant seal is the child class. Okay, let's proceed. Applying class access to class access modifiers. So this is for your class, no? Applying class access modifiers to your class. So you can apply your public, private, protected, or default class access modifiers. However, your private and protected classes. These are only for your inner classes, which I don't think we will discuss. We will be just focusing on public and your default, which is your package private. But usually, public is used for your class, no, if you're defining. But if you have, for example, two classes in one file, well, only one of those can be named public. All objects inherit from java.lang.object automatically. So this object is the only object without a parent class. So this is the top value. No? So if you're looking at the hierarchy, everything inherits from java.lang.object automatically. You don't set this na. If you remember sa autoboxing last time, diba? We had an int and then it was autoboxed to an integer. And then it was accepted to a method that accepts object. That happens because integer inherits the object class. So it's still considered one of the object class. No. Okay. Defining your constructors. We've been defining constructors since I guess lab 2 or lecture 2, but there are actually more rules to your constructors, no, that we have not yet discussed. So we'll be discussing this in detail now. So there are actually rules, as I've said. So okay, this is gonna be a lot of text, so bear with me. First statement for every constructor is a call to another constructor within the class using your this. So this is your constructor chaining, if you remember last week, or a call to a constructor in the direct parent class using your super. Take note, super in this case has parentheses. We'll see more of that later. So again, either you call another constructor from the same class, which is constructor chaining, or you are calling a constructor from a direct parent class using your super keyword. The super call may not be used after the first statement of the constructor. So if you wish to call super, it should be the first line in the constructor method. Okay. If no super call is declared in a constructor, Java will insert a no argument super as the first statement of the constructor. So as we see previously, when we are creating constructors, we are not calling this super method call. No, we're not calling a constructor of the direct parent class because Java automatically inserts this. So we don't have to call this if we don't require it. However, if the parent does not have a no argument constructor, meaning all your constructors from the parent class requires parameters, and the child does not define any constructors, the compiler will throw an error and try to insert a default no argument constructor into the child class. We'll see more of this later as examples because it's a bit harder to grasp with just words. Lastly, 5, if the parent does not have a no argument constructor, the compiler requires an explicit call to a parent constructor in each child constructor. We'll again more of the examples later. So for example, we have here public class animal. We have your int age and your string name. So these are both private now. Your animal here has two constructors. So one public animal here requires two parameters, and the other one requires only the age. So this one actually, these are two different. No? So the first line is super, so it calls a no argument constructor. So if this in this case, it does not extend any class, so automatically it extends the object class. So if you're calling super, it just calls the constructor from the object class, with no arguments here, no? Or no parameters. And then it just sets the field, age and name. Age and name, same here. So if you have another class, for example, here, gorilla, it extends animal. So this inherits the parent class animal. This is the child class now. It has this constructor. So this constructor has a parameter int age. So this just passes it to the super class. So this calls the super method, which is the constructor of your animal. It passes age and then gorilla. So it will actually call this, this one. So it assigns the private age and name. Note that you can't access age and name in the child class, but since we are calling the parent class, it can do it here. If we are calling here super 5, it is actually calling this method. Any questions here in this example? Okay, I'll be proceeding. We have here another example. Class mammal and public mammal and age. So this is your constructor of your mammal. If we call this class elephant1 extends mammal, what's wrong here? You don't have a constructor. So following rule number 5, I think, here, parent does not have a no argument constructor. Compiler requires an explicit call to a parent constructor in each child constructor. Also this one, no. So the parent does not have a no argument constructor in this case, and the child does not define any constructor. So if we look at it, so your parent mammal has no argument constructor, because all the constructors in the mammal class requires a parameter here, requires an argument, mammal int age, no. So if we extend it with elephant1, but we don't define a constructor, it will throw us an error because the Java does not know how to construct elephant1 with referring to your superclass or your parent class, because you can't construct this, no. You don't have a no argument constructor, so this will throw an error. Same thing here. This actually is number 5, I think, rule number 5. So your child class here actually has a constructor. However, it cannot call this one because this one is trying to call a no argument constructor for its parent class, but your parent class again does not have a no argument constructor, so that will be an error as well. So this is the error in the console. So for the first one, you have class elephant1 extends mammal. So this requires an int. As you see, the constructor requires an int, but you passed no arguments. So there's an error. Actual and formal argument list different length. Same with elephant2, no? You're passing this. So you're calling super with no arguments. You're calling this with no arguments. That is also an error. Okay. Next, in Java, the parent constructor is always executed before the child constructor. So this is why when we try to construct elephant1 with no arguments, no, it throws an error because it should call the parent constructor first. Sorry. So for example, here we have this code, class primate. We have it just prints primate here when you construct it. We have here ape, it extends primate. So it just prints ape. And then here we have your chimpanzee which extends ape. So when you when you instantiate a chimpanzee, so you're trying to create a new instance, it should call the constructor, right? So in this case, what will be printed first? What do you think will be printed first? Primate. Okay, so that's correct. Primate will be printed first, followed by ape. So if we actually, let me get my command line. Unit 6 CD examples. Okay, I'll be sharing my screen. Okay, so can you see the command line? Okay, we have chimpanzee. I've already compiled this, so I'll just call it again. If we do that, it prints primate and then ape. Because when you call new chimpanzee, it calls the constructor of chimpanzee. We don't have constructor here, but it's okay because the parent, it extends a parent with a constructor that has a no argument constructor. So it will call this, but this is a constructor of a child class. So it will again call the parent first. So it will print primate and then ape. And then you create your new chimpanzee class. So that's what happens when you call a constructor. Any questions? Okay, no questions so far. At any point, if you are lost or confused, just ask a question. Okay. Next, Java classes may use public or protected members of the parents class. I have said this earlier. Default members can be also accessed if both are within the same package. So again, your default access modifier, which is not putting anything, access modifier, is package private. So if your child class and your parent class are in the same package, whether it is default package or it is packaged with a name, you can use the default members. So those without the access modifiers. But if your parent class is in a different package, you cannot use the default members. Private members cannot be accessed by the child, or at least cannot be accessed like directly. No, you have to go through the getters and the setters of the parent class in order to access the private members. But if you're trying to access it directly, for example, you have your private class age sa animal example natin kanina, you cannot directly access that. You can explicitly reference a member of the parent class by using the super keyword. Now, take note, super keyword here does not have the parenthesis. That means that this is like a pointer to your super class. Similar to your this, no? So if you have your this followed by a parenthesis, that means it is a constructor. In your super, if it's followed by a parenthesis, it means it is a constructor of the parent class. If it does not have a parenthesis, it is referring to the parent class. So here, no? Super with parenthesis calls the parent constructor and must be the first line of the constructor, any constructor in the child class. Super refers to the parent class, and this can be accessed by used to access the members of the parent class. It can be used throughout your code or throughout your child object. Okay, Let's talk about inheriting methods. Child class can use the inherited methods given that it is public and protected, or default if it is within the same package from the parent class. Okay, child class can also redefine inherited methods. So if you have another method in the parent class and you want to do something else with it, or you want to do additional things with it, you can redefine that method, re-implement that method, and that is called method overriding. So here, for example, we have your K9. This is your parent class, no? So we have this method, get average weight, and it returns 50. And then we have your child class, wolf, which extends K9. So this is a child class of your K9. It has, here it redefines, no? It redefines get average weight as super.getAverageWeight. So this is accessing your parent get average weight plus 20. Take note here that if you return get average weight alone, this refers to the get average weight method of the child. So this will be actually an infinite recursion. So if you do this, no. But since we are calling super.getAverageWeight, this is calling another function, which is get average weight from your superclass or your parent class. So if we print that, okay, I'll share my screen again. Okay. So let's try that. Java, what is this? Wolf. Try to print that. Oh, there's a, ignore that. There are something else in the code. But take note of the first two numbers. Here we are printing K9.getAverageWeight, no? So this is the parent method. So we're instantiating a parent, a K9 class. So this is the parent class. If we get that get average weight, it returns 50. But if we call it from the wolf, so we're instantiating here a new wolf, get average weight, it is actually here. So it is redefined here. No, it is get average weight by the parent plus 20. So you get 70. Any questions with method overriding so far? Okay, so there's none so far. We'll proceed. Oh, okay. Anyway, there are rules, no, or limitations when you are doing your method overriding. So, method in the child class must have the same signature as the method in the parent class. So this is overriding again, not overloading. So that means that the return type and the number of parameters in the child class should match or should be the same as the method in the parent class. No? So same signature talaga siya. It's not defining a new method or overloading. The method in the child class must be at least as accessible or more accessible than the method in the parent class. So for example, you have a protected method in your parent class. When you try to override it in your child class, that should also be protected or public because it is more accessible. So you can change the visibility or accessibility of the inherited method, but it cannot be less accessible. So from protected, you can't do private. From protected, you can do protected or public. Okay. Next, the method in the child class may not throw a checked exception that is new or broader than the class of any exception thrown in the parent method class. Parent class method. This one we will discuss more about exceptions in Java next. Well, not next week. First week of November after you return from your reading break. Just know that exceptions are runtime errors. No, so if your methods throw an exception, if you inherit that method, it cannot throw like broader exceptions that is thrown by the parent class. We'll check more of that when we discuss exceptions now. If the method returns a value, it must be the same or a subclass of the method in the parent class, known as covariant return type. So this is subclass. This is just referring to your object references, no? So for example, you are in the parent class, you are returning a canine object reference. In the child class, you can return a canine object reference, or since wolf is a subclass of canine, sa example kanina, you can also return wolf. Okay. Overloading versus overriding. This just discusses the difference between overloading and overriding, and tells us that overloading is more flexible in this case. But, there are use cases that you would rather use overriding than overloading. Oh, okay. So I forgot to animate that again. Private methods, again, cannot be overridden because they are not accessible. However, your child class can redefine a method with the same name. So this ignores the private method of the superclass or the parent class. And when you call it from the child class, it will call that private method, the child's private method instead, even if it is the same name. Next is your hidden method. So this occurs when a child class defines a static method with the same name and signature as the static method defined in the parent class. So same name, same signature, same static method. This also follows the limitations or rules as you're overriding those previous four, but it has another rule. So the fifth rule actually is the method defined in the child class must be marked as static if it is marked as static in the parent class. This is method hiding again, no? Likewise, if it is not static in the parent class, it may not be static in the child class as well. So method overriding. So here we have an example. Bear, it has your static eat, static void, just prints bear is eating. We have your panda, which extends bear. So this is a subclass of your bear. This redefines your public static void eat. So same signature, same static, and same name, same parameter list. But this one prints panda bear is chewing. So if we call that in your main, let me check if I have an example for that. So if we have your panda, so it prints panda bear is chewing. It hides the static method from your parent class. So this is not executed. So this method is hidden because this is the method that you are calling instead. So this method is hidden. This method is the one that's visible. Gets? Any questions? Okay, maybe none for now. Again. Okay, let's proceed with the next one, inheriting variables. So this one is much simpler compared to your inheriting variables, compared to your inheriting methods. So in your variables, there is no overriding, only hidden variables. So you don't override the methods, no? You just only hide them. Hiding variable is done when the subclass have the same variable name as with the parent class. So for example, here you have class rodent, and it has protected int tail length, which is 4. And you have a get rodent details method, which just prints parent tail length. Mouse extends rodent, and then it has your tail length, again, same name, same int, but this one is 8. So when you print get mouse details here, it says tail length. So it prints the tail length here of the mouse. It also prints the parent's tail length, so super.tail length. So when we try to execute that, here, Java mouse. So when we try to execute, first it prints the parent tail because this here get rodent details. So it prints parent tail equals 4 because it refers to this one. It's the parent. But if we get mouse details, so it prints the tail length. So here we have hidden the tail length of the rodent class, the parent class rodent. And instead we use the tail length of the mouse class. So here we have tail length, it prints 8. But we can still access that member of the parent class when we call the super keyword. So super.tail length, it refers to this one, which is 4. So it prints 4. When is inheritance and method overriding, whatever, when is this useful? Personally, well, I was doing things with Unity, game development. So this is just personal experience. I was doing multiple enemies, and those enemies have similar behaviors. So each enemy has like different pathing, different shooting types, and I don't want that every enemy just shoots the same thing. So what I did was I extended the main shooting class or shooting object that operates the shooting, and then I overridden it in your for each enemy, I overridden the shooting. That's what so that when method shoot is called, it calls the shoot for every enemy, but the behaviors are different. So this is very useful when you are calling the same method, but you want if you want variations between those methods. So that's very useful for inheriting methods. Subclasses too, we'll see more applications sa inheritance in further down the line. But let's proceed with the next topic. Well, that's the output, which is your creating abstract classes. So this is again abstraction. So abstract class, abstract class is a class marked with an abstract keyword and cannot be instantiated. So there are definition rules here. Abstract class, this has usually does not have implementations. So this is just like your blueprint, Bale. This is just your outline. If you're creating like a speech, you have an outline. So you are defining methods here or variables, static variables, but you are not implementing those methods. You don't have like a code body in your methods. There are rules with your abstract classes. So this cannot be instantiated directly and may be defined with any number, including 0 of abstract and non-abstract methods. May not be marked as private or final because you cannot inherit things from a private class. And final classes as opposed to your abstract classes cannot be overridden. You cannot make a subclass of a final class. Abstract class that extends another abstract class inherits all of its abstract methods. We'll talk about that more as its own abstract methods. So everything that you inherit from the abstract class is now your own abstract methods. The first concrete class that extends an abstract class must provide an implementation for all inherited abstract methods. We'll talk more about what a concrete class is later. Abstract method, these are methods that are marked with the abstract keyword defined in an abstract class for which no implementation is provided in the class in which it is declared. Take note of this. No implementation is provided in the class in which it is declared. We'll see more of that later. So there are also rules here, may only be defined in abstract classes. So your abstract methods cannot be defined in your concrete classes. No, it may not be declared private or final because again, you cannot override or re-implement this if it is private or final. Must not provide a method body or implementation in the abstract class for which is it declared. Again, same no with this one. So that's emphasis that you cannot put an implementation if you declared it in that abstract class. Lastly, implementing an abstract method in a subclass follows the same rules for overriding a method. For example, the name and the signature must be the same and the visibility of the method, yada yada. You already know the rules for method overriding. Okay, so for example, here we have your public abstract class cow. So this is how you define your abstract class, no? So cow here does not have your methods. Okay lang. It's an empty abstract class bale. Here you have another abstract class dog, which it has a public abstract void method bark. So return type is void. It is labeled with abstract. And in abstract methods, you must end it with a semicolon. So you don't provide a definition for it or an implementation for it. So here we have semicolon, properly ended, no implementation here. Okay. However, here you have abstract class turtle. It declares abstract void swim, and then it is followed by your curly brace pair. So your curly brace pair, this actually signifies an implementation even if it is empty. So here we have an empty implementation of your swim method, and that is not allowed in your abstract class if it is defined in this same class. So same with get age, no? It returns 10, which is considered implementation. So it would not compile. Public class chicken here again, public abstract void peck. So you are declaring an abstract method in a non-abstract class. Here chicken, public class chicken. This is not an abstract class. It does not have your abstract keyword. So here you are trying to define or declare an abstract method. So that is also not allowed. More examples here. Public final abstract class tortoise. So what's the wrong thing here? You have both final and abstract. So a method can not be both final and abstract at the same time because these two are like polar opposites. Abstract does not have implementations and is meant to be overridden or redefined, while final should have all implementations and cannot be overridden or modified. It also cannot be a parent class anymore. So you cannot extend the final class. Public class, what's this? Public abstract class goat. Here we have public abstract final. So same thing now with the previous one. It is doing a public abstract final method. So that's also not allowed. Next, you have here public abstract class whale, but it is declaring a private abstract method, which is also not allowed because again, private methods cannot be overridden and abstract methods are meant to be overridden by an implementing class. Okay, next one we have, okay, we are correcting it now, no? Protected na siya, abstract void sing. Public class humpback whale extends whale. So this one you are reducing the accessibility of the method. So that is also not allowed. That is part of your overriding method rules, no, that you cannot reduce the accessibility. So here it's protected and then you reduce it to private. That is also not allowed. So those are just the examples, no, of your what is allowed and what is not for your abstract class and abstract methods. Any questions so far? If none, I'll take a quick break lang. Hello, I'm back. Let's resume. Okay, creating your concrete classes. So what is a concrete class? Again, abstract classes cannot be instantiated, but can contain static variables and fields. So you can access your static fields, no, if you have abstract classes, because again, your static fields require does not require an instance of the class. So even if you can't instantiate an abstract class, you can still have static variables with it. But to make use of your abstract class, you need to create a concrete class. So these are your first non-abstract subclass that extends an abstract class and is required to implement all inherited abstract methods. So the first here in this context just means that it is inheriting directly from an abstract class, because you can have two concrete classes that both both extends one abstract class. Okay, I have a few examples here. Let's take a look. I'm just finding it here. Okay. Share my screen. Okay. Here we have a public abstract class dog. It has 3 abstract methods. So it has a bark, walk, and jump. No? So these all have no definitions. So if we wish to implement it, we have to make a subclass, which is a concrete class. So I have here this one, Shiba. Okay. So your Shiba extends your dog. So this is a subclass. This is now a concrete class because it is non-abstract and it extends your dog directly. So directly from the abstract class, this is a concrete. So first siya, no, concrete class. So it is required to implement all 3 of this. So if we try to implement here, we have your bark and walk. We have implemented it. But if we try to compile this, since we did not implement jump, it will produce an error. So for example, Java compile Shiba. There you have public class Shiba extends dog. And then there's an error here. Shiba is not an abstract and does not override abstract method jump in dog. So it cannot compile because you did not implement or you did not override the jump method. I have another class here. So similar lang, no, with your Shiba. It also is not a tag dito. It is not implementing the jump. But in this case, it also directly inherits or extends your dog class. So this is also your first quote unquote concrete class, first non-abstract class. So this could be 2 concrete classes that are inheriting directly from your abstract class. What if we inherit an abstract class, dog, with another abstract class? We extend it to another abstract class. So I have here doggo. This class is, again, abstract. It can redefine jump. Why? Because it is not declared here. It is not declared in doggo.java. It is declared in dog.java. So this abstract class can actually override or provide implementation for your jump. So if we instead take Shiba and if it's not and change it to extends doggo instead of dog, and we'll see Shiba.java. Yeah. So if we try to compile it now, it compiles with no problem because it gets an implementation from doggo with a jump. And now it only needs to implement or override, provide implementation for bark and for walk. Gets ba? So yeah, that's for your abstract, for your concrete classes. Lastly, is you're extending your abstract class. Allows extending an abstract class with another abstract, as shown as shown in the example. Abstract classes can extend another abstract class and are not required to provide implementations of any abstract methods, but they can. It follows then that the concrete class that extends an abstract class must implement all inherited abstract methods. So as we shown, concrete subclass is not required to provide an implementation for an abstract method if an intermediate abstract class provides the implementation, as we've seen in Doggo. And that's it for your abstract classes. That ends the lecture for today. Did we end early? Well, technically late, but What time is it? 12:25. So, sakto-sakto lang. Do you have any questions? Do we have lab this week? Sir, can the fields in an abstract class have different values for different subclasses inheriting the abstract class? Fields in an abstract class have different values for different subclasses. Yes, so this is same with, I don't know, variable hiding, Jeremy. As we seen in the, what was that? A variable hiding sa previously, it's the same concept, no? So you can have like a protected field sa subclass, and then you just hide it sa imo nga subclass. Sa superclass different, and then different man sa subclass. So it is possible, yes. Anything else? It is same with, let me check if let us roll back quickly. So it's same with this, no? It is hiding the. Another question, sir. Can we use abstract classes a coffee machine? If you wish, you could. Pero yeah, you could if you want. It's not required to use abstract classes sa coffee machine, no? But if you want to, yes, you could. Also sa coffee machine, I've said sa lab na you don't have to implement a method for your off. However, that is still a requirement, no? If you type off, it should still end your program, should still turn off the coffee machine. I'm just saying that you don't need like a method for it. You could just put it somewhere else. But if you want to implement a method, go for it. Not a problem. Okay. Yeah, if you have more questions for later, you can consult again. So it does not need to be like if you have an issue, no, if you just have something to clarify, or if you like want your code to be, you want my opinions on your code, for example, see may nag-consult last week, no? That's also fine. Yeah, just message me. Also, please read the feedbacks for those who have received grades na. I'm working on your prime determinator. Should all be graded by today for those who have submitted already. For those who have not submitted any labs, you can still submit my deductions lang. Yeah. But that's it for me now. There's no more questions. You can dismiss. Okay. Budlay, sir. Budlay ang ano exactly ang budlay? Sorry. But anyway, that's it. No more questions. We can dismiss. Goodbye.